Yes, yeah, then audible. Yeah, am I audible?
Yes, sir.
Okay, so let's start with the Coulomb's law. So in the last class, I believe Pawan sir started something in electrostatics. You were in the last class, like last week? Yeah. Okay. But you are from the beginning of the crash course now. Okay. So, Mr. Shanavas is taking your mechanics, huh? So he must have finished this work, energy, power, and loss of motion, right? So what's the latest topic that he is taking? Mechanics. Okay, you did electrostatics for the others, right? Mr. Pawan is not available, so I'll be taking electrostatics from now on. So what did he taught you in the last class? Anyways, okay. So I'll start from the very beginning. Okay. So I will start from the very beginning and let's see how much you can recall. As compared to class 11, your class 12 syllabus should be very fresh, right? So we'll start from the very beginning. I'll start from the Coulomb's law. Iman, is there any problem with your audio device? Yeah, sorry. Fine. Okay. So we'll start with the Coulomb's law. So what does Coulomb's law say is you have two charges. That's fine. I have activated my this thing, my noise cancellation device. So it won't be a problem for you. So don't worry about the background noises. You can just switch on your audio device. It's fine. It won't disturb you. Because you can't answer everything by typing. So we'll start with the Coulomb's law. We'll try to finish a good portion of the first chapter, electric charge theory. So you have two charges, a charge Q1 and a charge Q2. They are placed at a separation R. So the force between them is given by Coulomb's law. Yes, yeah. Can you tell me what is the expression for the Coulomb's law? Okay, okay, okay. So you remember? Yeah, very good. K. So instead of K, I will write this as it's 1 over 4 pi epsilon naught. It's Q1, it's Q2 divided by R square. That's Q1. So what is the value of this 1 over 4 pi epsilon naught? The value of this 1 over 4 pi epsilon naught is 9 into 10 raised to the power 9. It's Newton meter square per coulomb square. This formula is valid only in vacuum or free space. This is valid only in free space. Means if you have two charges which are placed in free space, then they will exert electric force over each other, which is given by this. Now, if you place the same charges in a medium, like you place the same charges in, let's say, water or glass or in some other medium. So yeah, can you just tell me what changes will be here in this formula? If I place the same charges in any other medium than free space, like I place the charges in water, then what will be the change in this relation? Okay, instead of this epsilon naught, you will be using the K dielectric constant. This is K epsilon naught. It's Q1, Q2 divided by R. So this is the expression. K is known as the dielectric constant. Do you remember the value of dielectric constant for air? Yes, yeah. Do you remember the value of dielectric constant for air? See, the value of K is 1 for air. The value of K is infinite for conductor. So if you put these charges in a conducting medium, the value of K in that medium will be infinite. There is one more value of K that one should remember, that is for water. Its K is 80 for water. So this is the expression in air, and this is in any other. This is air, and this is in any other. Now, if I want to compare these two, then I can write that force in a medium is force in air divided by the value of dielectric constant. Okay, now can you just tell me which one is the higher value, the force in the medium or the force in air? Yes, yeah. Which one have higher value, the force in medium or force in air? Yeah, I'm asking. I have two charges. I've placed those charges in medium, and then I place the same charges in air. The force in medium is force in air divided by dielectric constant. Which one is the higher value? If medium is higher or air is? Yeah, the one is higher. So this is Coulomb's law, and there are some features of Coulomb's law. That is, it's valid only for point charges. It's valid only for point charges. Yes, Father, am I audible? Point charges or string. This Coulomb's law is not at all valid for non-point charges, valid for point charges or for string. Second is, it's valid only for static charges. It's valid for static. Just note it down and we'll start doing numerical now. Please note it down. Father, am I audible? Just note it down and tell me when you have, once you have written. What happened to your audio device, Father? Isn't it working? Okay, okay. Just note it down and tell me once you have written. We'll start the numericals. Yes, written. Shahid, we just have started Coulomb's law. Sure, okay, fine. So let's start. No, note it down, please. The value of the dielectric constant. Okay. So let's start with the first numerical. The first one is very easy. So you have two charges, Q1 and Q2. They are placed at a separation R. Separation R in air. They repel each other with a force. They repel each other with force. At what separation? At what separation? They must be placed in a medium of dielectric constant 3 so that force remains same. So the question is very simple. You have two charges. One is Q1, another is Q2. They are initially placed, Q1 and Q2 are initially placed at the separation R. When they are placed in air, then the force can be written as it's 1 over 4 pi epsilon naught. It's Q1, it's Q2 divided by R square. Now the question says you have same charges, Q1, Q2. You place them at some separation x in a medium. The dielectric constant of the medium is 3. The condition is the force is not changing. Force is still left. By changing the medium, the force changes. The force should decrease. The question says force is not changing. Just get the value of x. Solve it and tell me what is the value of x first. On the basis of this question, I will decide like what should be the next numerical. So very basic numerical, get the value of x to it first. Answers. No, Shahid. It should be in terms of R. Na? Where is R? Fadil, Iyad, answers. Should I try it again? You are not completely wrong, but your answer should be in terms of R, and there is some issue with the denominator and numerator. Yeah, then Fadil, if you're not able to do it, just write. No, just write no, I will give more it. Okay, fine. Fadil? Okay, I'm repeating the numerical again. So you have two charges that are placed at a separation R. The force is 1 over 4 pi epsilon naught, Q1, Q2 by R square. Now you have the same charges. You place these charges in a medium of dielectric constant stream. Now the force will not change, but you have to change the separation. Earlier the separation was R, now the separation is X, so that the force is not. So in a medium, you can write your F as it's 1 over 4 pi K epsilon naught Q1 Q2 divided by X square. You're supposed to calculate the value of this. So you're changing the medium, you are changing the separation, so that force will not change. What you can do now is just equate one into. Because both the forces are equal. Just equate one into. Do it, please. Do it. Just equate one into and get the value of X first. Just equate them and get the value of X. Answers, just equate these two equations and get the value of X. Fadil, are you calculating? Shahid, your numerator. No, yeah. No, R won't be equal to X. See, there is K also, no? The second equation. So see, when you equate them, 1 over 4 pi epsilon naught Q1, Q2 divided by R square, which is equal to 1 over 4 pi K epsilon naught Q1, Q2 divided by X square, right? So when you cancel them, Q1, Q2 will get cancelled out with this thing. 4 pi epsilon naught will cancel 4 pi epsilon naught. You are left with 1 by R square and 1 by Kx square. So you have 1 by R square. Yes, yeah, now you are correct. 1 by X square. So now you can write this as this means your square is R square by K, right? Now you can write that your X is it's R over. So your K is 3, so your X is ultimately it's R by root 3. Yeah, Shahid. Clear now? Shahid, you have to control these types of errors. Huh? Otherwise, these errors will not allow you to score in JEE. Check your calculation twice if you are habitual of these type of errors. Anyways, Father is not responding. Father, are you still in class? No response from Father is not in class. Anyways, Tharif, you are very late, bro. You're late by 20 minutes. So we just have started Coulomb's law actually, yeah. So it was the first numerical based on Coulomb's law. We'll start with the next. So from now onwards, see the type of numericals that you get in JEE from Coulomb's law are basically based on mechanics. Like it will include the kinematics that you have studied, it will include the dynamics, the laws of motion that you have studied, include the work energy part. So the first question, the next question here, this one, this will include Coulomb's law and the concept of tension. Can anyone tell me what is tension? You must have done this in laws of motion. What is tension? Quick answer. What is tension? You must have done this in normally this in laws of motion. Tension is the name of a velocity. Okay. Yeah. Tension is a force which acts in a string, right? Tension is a force which acts in a string. And how we decide the direction of tension? The direction of tension is away from the body. It always acts away from. So this question will include three concepts. It will include Coulomb's law. It will include the concept of tension. And it will include the equilibrium. So the question says you have two identical small charge spheres, each having a mass m. So this is the place from where you hang two spheres. This have a charge q. This have a charge q. Its mass is m. Its mass is m. This angle is theta. This is also. So the length of each string is L. This is L and this is also L. And the angle made by the string with the vertical is theta. Find the magnitude of charge on each sphere. So you have to basically calculate. Now, if this charge is in equilibrium, that means net force over the charge is zero. Can you tell me what are the different forces that are acting over this charge? Tarif, what are the different forces which are acting over this charge? This is sphere have charge q and mass. Just name any one force which is acting over it. Shahid, name any one force which is acting over this sphere. The first one is you're saying electric force, right? Yeah. So this Q and Q will repel each other and this will experience electric force, which is F.
Yes, sir.
Okay. Another force, Shahid, Tarif, Fadil, electrostatic force. Yeah, they've already mentioned this force, F. Another force which is acting over this sphere fast. Mass. You have mass, so there is one force which is weight acting downwards. And this is a string of length L. Name just one more force which is acting over this mass. Great. Tension. What is the direction of tension, Tarif? How does tension act? Towards the body or away from the body? Opposite to mg. Shayad is not the correct way to remember opposite to mg. Always remember away from the body. So this m is the body, so the tension will act away from it. So this is the direction of tension. So this is the direction of tension. It will act away from the body. This is the tension. Fine. So tension will act along the string and away from the body. So these are the three forces acting over the body, and the body is in equilibrium. So this force is acting along x-axis, this is acting along y-axis, and this T is neither x-axis nor y-axis, in between x and y-axis. So whenever you have vectors which are not exactly along x-axis or exactly along y-axis, what we do, we resolve. So this is theta, this is also theta. We'll resolve it. What will be the component of T in this direction? Anyone pass? Component of T in this direction, this name. Resolution of vector. Okay, Shahid, what is the component of T if this angle is theta in this direction? Resolution of vector. Just break this T into two parts. Yeah, T cos theta is acting upwards and T sin theta is acting in the leftwards direction. Now, if this is an equilibrium, then it's very clear now that right-hand side force should balance the left-hand side force. The force which is acting upwards should balance the force which is acting downwards. So you can simply write that electric force will be equal to T sin theta. Weight of the body be equal to T cos theta. Now what we can do is we can just divide this T and T will get cancelled out. Electric force. So let's call this separation. Can you calculate this separation from this right angle triangle? See, this is a right angle triangle. I need this separation. If this angle is theta, then what is this length? It's this perpendicular base or hypotenuse. What's the name of this particular length? I'm not going to write each and every step. Just tell me what is the side? It's perpendicular base or hypotenuse. It's a right angle triangle. Huh? Okay, it's perpendicular, opposite to theta, right? So this is perpendicular. No, it's not a base. See, this is angle theta now. This side is opposite to the angle theta. The side opposite to the angle theta is perpendicular, right? So this is perpendicular, this is theta, and what is this side? This L. T, B, H. What is this L? Fast. This is perpendicular base hypotenuse. This is hypotenuse, right? This is H. The right angle triangle. This is H. Huh? So in this right angle triangle, sine theta is this length. I call this as X. Sine theta is perpendicular by hypotenuse. So this is X divided by L. How much is X here? So your X is L sine theta. See, this length was not given, but I need this length to calculate force using Coulomb's law. So this is, how much is this? This is L sine theta. Now, can anyone tell me how much is this length? This one. Same angle, theta, same L. How much is this length? Shahid, Iyad, Tarif. How much is this length? See, it would be easier if you can just switch on your mic. Huh? Same, right? So this is also L sine theta. Okay, so and what is the distance between the two charges? For Coulomb's law, you need separation between this Q and Q. How much is the separation? So I'm writing Coulomb's law 1 over 4 pi epsilon naught Q multiplied by Q divided by S. What is the separation between these two charges? L sine theta or twice of L sine theta? It's twice of L sine theta, right? So it's 2L sine theta whole square, which is equal to tan. So you are supposed to calculate the value of what? Your value of charges. You can write this as Q square is, just take everything to the right hand side. Huh? It's 4 pi epsilon naught. The square of this will be 4 L square sine square theta. This is Q square. So what would be the Q? The value of Q will be root over this. Huh? So it's 16 pi epsilon naught pi L square. This one tan theta also. L square sine square theta tan. Aji, clear? So this is what you were supposed to calculate. Is it clear? Tarif, Fadil. Okay, just note it down. Note this numerical. And then write, then we'll do this numerical. Second. Just note it down. Please note it down. Please tell me once you have written. We'll start with the next week. Yes, if you have written, can you move on to the next numerical? Okay, just tell me once you have written, then what will it? Tarif, written? Sorry, you were not audible. Can you please tell me again? You're saying something.
Yes, written.
Written, okay. Fadil, Shahid, Iyad. Okay, fine. So this numerical use Coulomb's law and the concept of tension and equilibrium also. Yeah. And the next numerical will include the Coulomb's law and the friction. So the question says, just read this question. So particle A having a charge of 2 into 10 raised to the power minus 6 coulomb is held fixed on a horizontal table. So this is from HCV. A second charged particle of mass 80 grams stays in equilibrium on the table at a distance of 20 centimeter from the first charge. So you have two charges, right? This is charge A. Its value is 2 into 10 raised to the power minus 6 coulomb. This is the first one. Then you have another charge. It's charge B. This is unknown. B is unknown. The separation between these charges is 10 centimeter. And the mass of B is given. Its mass is 80 grams. So this has some mass also. So I will write it here. The mass of B is 80 grams. And this B is not moving. This B is in equilibrium. This B is it's not going anywhere. The coefficient of friction between the table and its second particle is 0. So between the table and the second particle here, the coefficient of friction is 0.2. This is the coefficient of friction. So mu is 0. So you are supposed to calculate the charge on the second sphere so that it does not. So now, can you just tell me what are the different forces which are acting over the charge at B first? Name some forces which are acting over this charge at B. Think about it. Sharif, just name one force which is acting over this charge at B. One force.
Sir, can you repeat?
Sorry?
Can you repeat?
Yeah, I'm saying just name one force which is acting over this charge at B. This particle B have some charge. This must be experiencing some force. Just name one force which is acting over it. Shayad? See, this is a charge particle. This is also a charge particle. If this is, say, it's also a positive charge particle, right, Father? So these two charge particles should repel. So this B will experience an electric force at E. B will experience an electric force, right? So due to this electric force, this B should move away from the charge. But here is some friction. Now, can just anyone tell me what does friction do? Friction support motion, it opposes motion usually. What does friction do? Friction support the motion of two bodies or it opposes? Very good. It opposes the motion. So if electric force is trying to push this charge in the right hand side direction, the friction will try to push this charge in the left hand side. So this charge is in equilibrium. That means friction should get balanced by the electric. Now, does anyone remember the formula for friction? Does anyone remember the formula for calculating friction? You have to finish friction last week, I believe. Last week. The laws of motion. How can we calculate friction force? Just turn your notes and check how you calculate frictional force. The formula for calculating friction. The formula for calculating friction is mu n. So mu n is equal to electric force. And what is normal reaction? Normal reaction is equal to the weight of the body. N is normal reaction, which is equal to the weight of the body. So you can write mu mg is equal to the electric. So your mu mg is, what's the formula for electric force? Electric force is 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught. Charge on A, then charge on B divided by R square. See, everything is given. Mu is 0.2, MB is 80 gram. How will you convert this gram into kilogram? How will you convert this gram into kilogram? You will multiply it with 10 raised power minus 3, this much of kg. How much is R? R is 10 centimeter. So to convert this 10 centimeter into meter, you just multiply it with 10 raised to the power minus 2 meter. What is QA? QA is this. You're supposed to calculate QA. Yes, everyone, did you get up to here?
Yes, sir.
Okay, so now what you're supposed to do is just put every value, put mu, m. What's the value of G? Acceleration due to gravity. How much is G? Value of G?
10 or 9.8.
9.8, or we can take it to be 10, approximately 10. Just substitute the values, put mu, m, g, 1 over 4 pi epsilon naught, you know it's 9 into 10 is power 9. Put the value of R, which is this, and get the value of Q. We do it fast. Okay, I just need 5 minutes break. I have to offer namaz, so just do it. Get the value of Q. You have 5 minutes. You at least need 5 minutes to finish. Do it. Is it clear to everyone? What you're supposed to calculate? Fadil, Tarif, Shahid, Iyad. Do it. Do it. Get the value of QB. You have 5 minutes. Get the value of QB. And please don't check this numerical anywhere from the internet. The simple calculation is just multiplication and division. If you're not able to do multiplication and division, how will you crack the? Put every value, get the value of QB. And don't worry whether your answer is correct or not. Do it honestly. Yes, answers. Shahid, Harif, Fadil, answers. Was anyone able to solve this numerical, or I have to solve it? Okay, let's do it together. Huh? So you need QB. So what you can do is just substitute our values. Friction, it's 0.2. Mass of the body is 80 grams. So that's 80 into 10 raised to the power minus 3. G is 10. 1 over 4 pi epsilon naught is 9 into 10 raised power 9. Then you have QA, which is simply 2 into 10 raised power minus 6. Then you have QB. Then you have R square. R is 10 raised power minus 1. So minus 1 square is 10 raised to the power minus 1. So just take all things to the right hand side. So it will be 0.2 into 80 into 10 raised to the power minus 2 divided by this whole 9 into 10 raised to the power 9 multiplied by 2 into 10 raised to the power minus 6 into 10 raised to the power minus 2, which is equal to 2. Right? So you just have to do this, all these calculations. So when we divide them, this 2 will cancel this 2, it will be 0.1. Then you multiply 0.1 with 80, it will be 8. So numerator you have 8, denominator you have 9, then you have power of 10. It's minus 2 into minus 2 minus 4. 9 minus 6, 3. 3 will go the minus 7 coulombs. Did any one of you get this answer? No. Okay. Is it clear? This calculations now we'll move on to the next topic. Fadil, Tarif, Shahid, Yad. Is it clear?
Yes, sir.
Okay. Just note it down. We'll start the electric field. So the type of questions that you get on Coulomb's law will have Coulomb's law and entire mechanics that you have studied. That's why in this crash course, we first start with the mechanics because you can't solve numericals if you don't know mechanics. I hope you have written it. Yeah? Let's move on to the next topic. The next topic is electric. So you know electric field. What is electric field if you have a charge? The first thing is its property of a single charge. For electric force, you need at least 2 charges, but for electric field, you need just 1 charge. So this is property of 1 charge. One single charge. The property of one single charge is electric. So if you have a charge field, then there is a space around the charge in which its electrical effect exists. If you bring any other charge, then this charge can exert attractive or repulsive force. This space around the charge is to calculate electric field, the general relation is its E is force experienced by the test charge divided by the magnitude of test charge. This is how we calculate it. Now, for JEE perspective, no one is going to ask the definition of the electric field, but you should at least know the unit, SI unit. Can anyone tell me what is the unit of electric field? SI unit? Unit of electric field. SI unit of electric field.
Volts per meter.
Yeah, there are 2 units, right? You can either write Newton per coulomb or you can write as volt per. So these are the 2 units of it. Then you should also be able to write the dimensions of electric field. Sometimes dimensions are important, particularly in electrostatics. So to write dimensions of electric field, So you should know the dimensions of force. Force is mass into, so just break it into the fundamental quantities. So you can write force as mass into acceleration, and you can write charge as current multiplied by time. So your mass is fundamental, your current is fundamental, time is fundamental, but acceleration is still not fundamental. So keep on breaking this acceleration. So you have m current multiplied by time. What is acceleration? It's velocity, change in velocity divided by time. So mass is fundamental, current is fundamental, time is fundamental, but velocity is still not fundamental. So break velocity. What is velocity? Displacement multiplied by time. So in denominator you have t square. Velocity is distance, displacement divided by time. So now this is the dimensional formula. Like mass have its 1. What is d? Its distance, which is length, power is 1. Then you have time. Time is in denominator, it's cube. So that's 10 raised to minus 3. Then you have current, A. We represent current by its denominator, so the power is 5. So this is the dimensional formula for electric. So in class 12, all quantities that you know, like electric field, magnetic field, capacitance, energies, potentials, you should know the dimensional formula of it. So for each quantity, you should remember the formula. I believe you know the formula because you just have attended class 4 exam. Then after formula, you should know the units, SI units, and after SI units, you should know the dimension. So this is how we write the dimension of electric. Fine. Now, once you know the electric field, you should know the formula of electric field for different types of charge quantity. So first we will start with the point charge. So if you have a point charge, then how will you write the formula for electric field? Can anyone just tell me the formula of electric field for a point charge? If you have a point charge, I need electric field at a separation of R. What would be the relation of electric field? Anyone? Expression of electric field at a separation R.
E is equal to k cube.
Yeah, so E is k q by R square. That is the expression for electric field for a point charge. How we decide the direction of field? If you have a positive charge, then the direction of field is away from the charge. But if you have a negative charge, then the direction of field is toward the charge. This is the direction of field for charge. And if I want to plot E versus R, see, your E is inversely proportional to R graph. So E versus R graph will be hyperbolic. Keep on increasing R, the but instead of E versus R graph, if I ask you to plot E versus 1 by R. So for this type of graph, put 1 by R as something. Let's put 1 by R as X. You know that E is KQ by R square. So we'll write this as E is KQ. Instead of 1 by R, I'm writing X. So it's KQ X square. So you can say E is proportional to X square. Can anyone tell me the shape of the graph if you have a quadratic type relation?
Straight.
No. For straight line, it should be a linear relation. It's not straight line. It's quadratic that the graph will be parallel. This time, parallel. Right. So this was for the point charge. And then for a point charge, you have superposition principle. So the superposition principle says if you have a number of point charges, superposition principle. It says if you have a number of point charges, you have a charge Q1, you have another charge Q2, you have another charge Qn, and you are supposed to calculate electric field here. Sorry, this is Q1. So all charges will generate their electric fields here. First charge will generate its field E1, second charge will generate its field E2, nth charge will generate its field E. All charges will generate their fields. So the net field would be the vector sum of individuals. For the net field, what you can do is you can just simply vectorically add all individuals. E1, E2, up to. So this is the net field. That's superposition principle. So if you have a system having n point charges, the net field at a point is the vector sum of field charges. The next is Next, we can do some problems on superposition principle. First, we will do the problems on symmetry. It's very, very important. Before symmetry, let's do one simple calculation. So you have 4-point charges. One charge is Q plus Q. Another is plus 2Q. Next is minus Q. Another is minus Q. Let's consider this as a square of each side A. All are placed on the vertices of a square. Thus, each side of the square is. You're supposed to calculate the electric field at O. Calculate field. First, note it down, then we'll start this. Please note it down. And please write fast. Yes, everyone have written up to here? Scroll it.
Yes, sir.
So let's start with this summary. You're supposed to calculate field at point. So can anyone tell me how many fields will be acting at point O? You have 4 charges. Quick. How many fields are acting at point O? You have 4 charges. You can use the chat box also, no? Each charge will generate its own field, right? So you have 4 charges. That means at the center you'll be having 4 fields. So this is charge number 1, this is charge number 2, this is charge number 3, this is charge. So each charge will generate its first charge will generate its field, which is away from the charge. Second charge will generate its field, which is again away from the charge, the positive charge. भाई मुझे पता है आप लोग थक गए, but still ना कुछ ही दिन की तो बात है. कुछ एफर्ट्स और वरना साल भर की मेहनत खराब हो जाएगी. आप इतना जल्दी थक जाओगे तो सारी मेहनत खराब. Just tell me, third charge. It's minus q. What's the direction of field? It's away from the charge or towards the charge?
Towards.
Towards the charge. Fourth charge, minus 2q. It's again a negative charge, so the direction of field is towards the charge. So the net field will be the sum of all. So what we can do here is, we can first add this one, E1 and E3. They're acting in same direction, so no need to apply any vector law. This E2 and E4, they're again acting in the same direction, add them up. First, we will add E1 and E3, then we will add E2 and E4, and finally we will add the combination of E1, E3 and E2. So I can write E1, 3, which is the vector sum of E1 and 3. Now, since E1 and E3 are acting in the same direction, that does not matter. You can directly add them. Plus. Now, E1 and E3 both have same charges. If side of the square is A, can anyone tell me how much is the separation? Is it A? It's A by 2, it's A by root 2. How much is the separation? Half of the diagonal of the square. See, you have a square of side A. The diagonal of the square is A root 2. And the separation that we are using from here to the center, it's half of the diagonal. So that's A root 2 by 2. So it's A by root 2. So this separation is A by root 2. This separation is again A by root 2. This is again A by root 2. And this is again A by root 2. So if I want to calculate E1, then E1 will be K, charge is Q, separation is A by root 2 whole square, it's KQ by R square. So this KQ, A by root 2 whole square. Similarly, E3, see E3 and E1 have same charges, so the magnitude is same. The only difference is in the direction. It's KQ by R. It's again A by root 2 whole square. So when we add them out, it comes out to be it's 2KQ by A square by 2. So you can write this 2 into the numerator. So this is 4KQ divided by A square. So that's E1. Similarly, you can calculate E24. What is E24? E24 is the sum of this E2 and E4, these two vectors. So this is the vector sum of E2 and E4. Now again, since E2 and E4 are acting in same direction, both are acting in same direction, there's no need to apply the vectors law. You can just directly add them. So E24 will be the vector sum of E2 and E4. How much is E2? E2 is its KQ. It's KQ by A by root 2 whole square plus E4, which is again KQ by it's A by root 2 whole square. So this is again sorry, the charges is not Q, that's 2Q now. So it's K into 2Q, K. So you have, when you add them up, it's K into 4Q. In the denominator, you have square of A by root. Square of A by root 2 is A square. Next, what you can do is you can just take this 2 in the numerator and you will write 2, 4 will be A into 8 cube divided by x. So this is E13 and this is E24. And this E13 here and E24 here, they're acting at 90 degrees. The angle between the diagonals of the square is 90 degrees. So for the net field, you have to add E13 and E13 and so when you add them up, you have to use the parallelogram law. You have two vectors which are perpendicular to each other. So the resultant is root over a square plus b square. So this will be E13 square plus E24 square. When you substitute the values, how much is E13? E13 is 4k cube by a square. So it's 4k cube divided by a square, it's whole square. 24, it's k8 cube by a square. 8k cube by a square and whole square. So you can take some things as common. Like k cube by a square whole square, you can take it as common. So you have it's k divided by a square root over 16 plus 16. So you have E is it's k cube by a square. This is root over. So this is the mix. So this is how you solve the problems of superposition principle. So if you have more than two charges, just calculate field into individual charge and then add them up into it. Do it and then do some problems on second. Is it clear? And please don't copy the calculation. Do it yourself. Tarif, is it clear?
Yes, sir.
Don't copy the calculations, sir. Do the calculations. Please tell me once you have it. Start with the problem concept. Okay, so start time is in some minutes. I should leave. Okay, fine, then I'll stop. Iyad, you're from Riyadh or from Dabba? Okay. Okay, if this is the start time, then I will stop and we'll continue this next part. Meanwhile, please note this numerical at least. Iyad, you can leave now. Huh? Okay. Madam Tharif written.